All right, welcome back. We're going to do section 13.3, which is hyperbolas. Hyperbolas, very similar to the ellipses in their general format, though you'll notice that there is a subtraction symbol there, and that's the whole key. You can know a conic section is a circle or an ellipse if both x squared and y squared are present and positive. You'll know that it's a hyperbola if x squared and y squared are both there, but one of them is negative. And if the y is negative, the x is positive, then it's horizontal. And by horizontal, we mean sideways parabolas, if I can say. The two parabola type things, the two halves of the hyperbola, are in this direction. And if the y is positive and the x is negative, then you have them one over the other. A more traditional up and down thing. All right, so do we still have a major minor axis? Not necessarily. What we have are things that describe the rectangle between them. So let me graph this one right here. This is x squared over 16 minus y squared over 9. We can see my center, which is no longer really a center anymore. But my center is, what am I subtracting? What am I subtracting? It's just 0, 0. So what I'm going to do with this is I'm going to graph this knowing that it's at the center, and in my x direction, what's the square root of 16? 4. So from the center in the x direction, I'm going to go 4 out both ways. 1, 2, 3, 4, there's a point. 1, 2, 3, 4, there's a point. And then in the y direction, I'm going to do the same thing. It's 3 plus 9, so square root is, see, 1, 2, 3, there's a point. 1, 2, 3, there's a point. So it's very similar to the ellipse at this point, right? Well, now what I'm going to do is I'm actually going to make a rectangle for this. And then I'm going to connect the diagonals, or draw diagonals in, extending them way far out. Far out, dude. Sorry. So now I've got this, and now you can see that I've got 4 different locations for either hyperbola sections here and here, or here and here. And how do I know which one is which? Well, this is x squared, positive, y squared negative, so it's a horizontal. So that means I have my hyperbola sections starting here and getting closer and closer to those lines, like so. And that, the red, the only thing that is the hyperbola is just the red. Now there are a couple of points here. These right here, this right here is 4, 0. This is negative 4, 0. Those are my vertices. Just like the vertex of a parabola, it's the point right here that's closest to the other half. Those are the vertices. Does that mean that 0, 3, and 0, negative 3 could have been vertices? If it had been vertical, you betcha, it sure would have been. So how do you know? Well, the vertices are going to be the plus or minus along with the variable that's positive. This is plus or minus 4, 0. If it had been y squared over 9 minus x squared over 16 equals 1, it'd have been 0 plus or minus 3. Right? So let me show you what this looks like with Desmos. And I'm sure they do a slightly better job with their accuracy. Only slightly though, mind you. So the one that I just graphed was this one. And there it is, look at that. 4 and negative 4. Does it show you what the vertices are? Yep, sure does. You can click on those and see what they are. That's pretty sweet. If we had graphed the other one, we'd see this with vertices of 0, 3, and 0, negative 3. I threw these lines in here just for fun so you can see how those boundaries serve as some pretty good, I mean, it no longer looks like a parabola. It looks like just 2 intersecting lines. And that's what we have with those hyperbolas. And this would have been the same boundary type thing. boy, there's a whole lot of practical value, and I know sometimes it doesn't seem like there are practical value in the ellipses and the hyperbolas. There really are, especially for pinpointing locations of earthquakes, finding centers of orbits, and for satellites and comets and all kinds of different things. But we don't have time for that. We want the practical stuff, and that's it. One more section in this chapter, that is section 4 on hyperbolas. I'll see you then.